In this video, we will explain the Fetch-Decode-Execute cycle. Let's have a look and resume the components that we explained before. So the CPU contains two main units: the control unit, which manages and controls the flow of data and instructions within the CPU, while the arithmetic and logic unit is responsible for carrying out arithmetic and logical operations. We also have registers that are small and fast storage locations used to hold data temporarily. Content of registers can change millions of times a second while a program is running, because registers can store 64 bits or 128 bits. This is random access memory of RAM. Memory location has an address. These addresses are numbers ranging from 0 to something very big, even 8 GB of RAM, which has over 8 billion memory locations and therefore over 8 billion memory addresses. The CPU is connected to the RAM by the data buses, the address bus, and the control bus. So here's a line of code written in a high-level programming language like Java or Python. This code can be understood by humans, but the CPU cannot understand it. It needs to be translated into machine code, binary ones and zeros, because that's all the CPU can understand. This translation can be done using a compiler or assembler. You will find more details about this in the next videos. Let's focus on how the CPU works and how the Fetch-Decode-Execute cycle is done. This code can be translated to low-level code, like this assembly instruction, and to machine code zeros and ones. This means that the CPU loads the first number from memory location 3, then adds a copy of the second number from memory location 4, finally stores the results back into memory location 5. So let's explain how these instructions are being executed. The instructions have already been loaded into main memory. These instructions are stored in binary machine code, but it's convenient for us to visualize them like this. First, the program counter contains the memory address of the next instruction to be fetched. This memory address is copied in the memory address register, which makes it available to the address bus, so it can be copied to the memory controller. The control unit issues a read instruction to the memory controller using the control bus, which means the CPU wants to read something from the memory. The contents of the memory location 6 is copied using the data bus in the memory data register, and from there it's copied into current instruction register. Now the first instruction has been fetched. After that, the program counter is incremented, so the program counter contains now the memory address of the next instruction to be fetched. The control unit decodes the instruction load 3, then puts the memory address 3 in the memory address register, overwriting what's already there. This makes it available to the address bus and it's copied to the memory controller. A read instruction is then issued. The content of location 3, the number 20 in this case, is copied to the data bus and then to the memory data register, overwriting what's already there. Then it's copied in the accumulator, so that's the first instruction fetched, decoded, and executed. To fetch the next instruction, the content of the program counter is copied in the memory address register, then copied to the memory controller using the address bus, and the read instruction is issued by the control unit. The second instruction is placed on the data bus, and copy it into memory data register, replacing what was already there. Next is copy it into current instruction register. And the program counter is incremented. The new current instruction can now be decoded and copied in the memory address register and sent to the memory controller using the address path. A read instruction is issued and the content of the location for the number 30 is copied to the memory data register. The number 30 is now passed to the arithmetic and logic units, which will add it to the value that's already in the accumulator. We notice that whenever the memory is read, a memory address has to go into the memory address register first, and whenever anything enters the CPU, it has to come through the memory data register. The program counter is already pointing to the next instruction to be fetched. The content of the program counter is copied to the memory address register and then copied to the memory controller using the address path. And the read instruction is issued. The instruction at the memory location 8 is copied in the memory data register using the data bus. From there, it's copied to the current instruction registers. Here the program counter is incremented. This time the CPU is going to write something to the memory, where the instruction says to store a copy of whatever in the accumulator into memory address number 5. So the memory address is copied in the memory address register and sent to the memory controller using the address bus. In order to execute this particular instruction, the contents of the accumulator are copied to the memory data register. A write instruction is then issued by the control unit and the data is copied using the data bus into memory location 5. And that's the program completed. The fetch-decode-execute cycle can be summarized in 4 steps. Fetch. The CPU fetches instruction and data from RAM. Decode. The control unit decodes the instruction. Execute. The ALU executes instruction and operates on data. Store. The processed data is stored in the RAM.